we've switched roles. I'm gonna try to put this together.
We'll have you put on safety glasses.
It's really deceptive how big this building is.
So we'll start talking about blocks. So our blocks are made in the USA. They're cast in the Midwest. They come to us, we get them. The only thing that's really done to them is when they come out of the foundry, there's some raised metal and stuff on there. So they go through and remove those. So when we load them inside of the machines, it doesn't throw off the machining or make it so it can't be loaded. From there, each one of these machines performs a different function. So if you look at how a block starts when it goes in, every step along the way, we're just breaking up the machining into small bite-sized pieces. So it's kind of like how you eat an elephant one bite at a time. That's how we machine a block. So when we go in, you can see that we'll start out and we'll do the ends. So we'll do the bell housing, the timing cover, a lot of the starting of the bolt holes and things of that nature. And as you go through along the way, you can see different steps have been completed. So this one, the lifter bores aren't done. The deck isn't finished yet. The oil galleys don't look like they're completely done yet. So you can see the transformation from that casting and see how it's starting to look like a machine block. When they come out and they're finished, this is after that first operation. You can see that a lot of it is still in place. Our second operation does a lot of rough machining, so it goes through and just removes a bunch of material. And then when it gets down to the end, after we've got a lot of the main machining done, we put on the mains. You can feel that there. It's not fully machined and smoothed yet.
Oh, yeah.
So what will happen is one of the coming operations, they'll actually size that for the crankshaft. And then after that's all done, it comes out and it's gonna go through our line hone machine. I'm gonna grab somebody and show you how we do this. CNCs do a great job of holding very tight tolerances for us. And once they come out, the last step is to finish the main journal. And so one of the things that we do is there'll be a little bit of coolant, and you've got these stones that are designed to go in and really dial in the main journal for the crankshaft. So Chad is going to show you how the machine operates, and you'll see a theme from what you witnessed with David. You know, if you look at this machine was designed and manufactured by our team. So David, who explained the block washer, also took the lead on this one. So you'll notice a simplification from what you usually see in a line honing.
Tell them about the curtain.
Yeah, so this is the light curtain. So there's a beam that goes back and forth between these two bars, and if somebody accidentally puts their hand in it or their shirt or something, it'll shut the machine down right away as a safeguard.
Like a fancy garage door.
Yeah, it's exactly the same concept.
All those sprayers in there are like perfectly pointed. That's so cool. Will this just run through here once, or do you make multiple passes? Wow.
One pass. Those are very specific stones that were designed for this application. Once it goes through and does that pass, it's sized and ready to go. That won't get touched again until we start installing bearings in it. It'll go through a wash tank, but that micro sizer takes it to the point where it's ready for the main journal bearings to be installed.
That's crazy. So it goes from the raw, bumped out, like unfinished state to ready to rock in one pass, just like that.
When they're done, and this is a pretty cool shot when you look at the number of blocks. Each one of these different colored sheets of paper sticking out of it tells us it's for a different engine application. So you know, you think about the block itself, there will be provisions for fuel pumps.
Yeah. Where
you can see it's got the fuel pump, the mechanical fuel pump holes machined in it. There will be other ones over here. You can see that it's not machined in there. And then we have a block where we've got a piston oiler in it, and so those other ones over there, there's an actual hole where you can put a manifold in there and put oil on the pistons and turbo applications. Now if you feel, you remember that step you felt on the other side?
Yeah.
That step's completely gone.
Yeah, that's like done. You can't feel it at all.
Exactly. These are all V8 small block Chevy, kind of your 350 to 383 application for our product line. That's what you see, the spaces in the plant. It's for capital expansion where we can buy new equipment, put it in place to do more and more of our own blocks.
Are small blocks like your most
That's
volume
our most
thing?
popular product line, both from the industrial side and also on the performance side. That's where most of our volume is at right now.
After they are lined up in the Field of Dreams here, where do they go after that?
So when these guys are done, they'll go right over to the cylinder hone. So on the cylinder hone, this bore for the piston is about 98% complete over there. We use some honing stones, and if we can go over and take a look at that. And when they do that, you're really doing two things. You're making sure you get a good crosshatch inside the cylinder and a good plateau finish bucket section. So this area here is all being cleared out for expansion.
We're right in the thick of it now. Throwing blocks around.
So this is the cylinder hone. You can see there's a tool head in there that's rotating and moving up and down, and you can see what it's doing here inside of the machine. So each block has its own specified target that they have to hit when they machine, and this is the machine that makes sure that that's how they get finished. So you can take into account, you can put in the amount of stock you need to remove. You can make sure that you remove or have the right amount of taper inside of the cylinder. So when this is finished, we know that it's ready for pistons to be installed in it.
So what's the actual transportation process from the block from that thing to over here? Like,
So if you look up and down the line, you'll see these hooks.
yeah.
So they will actually grab the block by either the main journal or certain holes here, and they can pick it up and transport it and put it inside the machine. So once the blocks come in on the pallet, the rest of the way it gets lifted and brought all the way down the line. From there it gets put on this table. So this is that manual wash we saw the robotic wash of before. So you can see there are two takes for it. So again, we're able to combine and minimize the footprint that it takes, which allows us to put more equipment in the plant. On this side, you got a really hot wash that gets everything loosened up from the process. And on the other side, you're doing a brush wash and getting the rust preventative on them so they don't rust as they go through the plant. This is where everything comes together to finish that block. It won't be machined after this step. So what this does is it takes a block that's already been, so if we buy one that we didn't CNC machine here, we have to go in and bore them out sometimes. If you have a block that's a 4-inch bore and you want to go to a 4-inch 40, you do that in that machine. The other thing that you're doing in that machine is you're doing the final pass on the deck.
Is this the original version of what that is?
The original line hone, so you can see it's a very manual process for the operator. They go through, they remove stock, and then they inspect each one of those journals to make sure that it's right. If one size, if you think about wear and tear from an older vintage casting, the caps and the journals may have worn a little bit differently, so this helps make sure that you true up each one individually, and that's what he's checking right now with his gauge. After an engine is washed, we put in the camshaft and the cam bearings. It goes through the paint booth. We've got a couple of different options. You can see we've got like a raw LS block, which people really like that option. We've got the old school Chevy orange as an option. And then for some of our Ford engines, we've got a Ford blue that we paint the engines. And really what it allows customers to do, if they have a preference, they can paint the block whatever color they want. Otherwise, they can just take our base option.
How does the paint booth work? I want to see that.
It's a very manual process. We'll go around this.
This place is intense. I'm just a sponge right now.
So this block is prepped to be painted, so you can see how we put plugs and magnets. We block that stuff off so you don't get any paint inside there. It's just like you're used to seeing somebody painting it by hand. They'll go through and they'll make sure that they get all of the angles. They'll rotate it. They'll flip it up so we can paint the bell housing. And it gets a really nice finish coming out of the booth. It's simple and it's effective, and it really works for what we're trying to do. Just a magnet.
This is like a refrigerator magnet?
Exactly.
That's so cool. You got some stuff that's like super refined, cutting edge technology, and then magnets and paint booth.
Yeah, and if you think about it, like that's just a different size soft plug. We're willing to invest, but we want our investment to go where it adds the most value for our customers. Investing in CNC equipment and in a really tight tolerance capable equipment is really important for us. For us, whether you spend hundreds of thousands of dollars on a sophisticated paint booth or you use some magnets and have somebody do it by hand, the quality ends up being the same in the end. So, you know, as our volume goes up, the capital investment to put an automated booth in might make a lot more sense, but for what we're producing today, having somebody do it by hand still works for us very well. Now you can see like this is for like for a Ford. So you can see how it's blue, but the water pump surface on a Ford is different than a water pump surface on a small block Chevy.
And the finished ones roll over there?
Yeah, we're in the process because of our volume of splitting up the line. So this line right here is a lower volume, high mix line. So this line would run, this is a big block Chevy, this is a big block Chevy, that's a 509. We would run our 632s, 572s down this line. Eventually our LSs will run down this line, and you can see everywhere you see a blue station, the operators have built their own workstation for use inside of the line. So we give them the ability to set up their workstation in a way that means more to them. So instead of me saying this is how your station is going to be, they get the chance to go through and set that up. So this is a new line that's in development for us, where we'll be installing technology like a head robot, which we're going to see here in a little bit, things of that nature. But on this line, an operator would do the crank, the timing, the lifters. You know, they're going to do multiple steps in one, so they have to do more steps. When we get to the main assembly line, you'll see the build is broke down into like 15 or 20-minute chunks where it's crank install, timing install, rear seal install, piston install, oil pan install, and it's broke up. So we develop our assembly line based off of what volume we need to hit for the day. So we look at the takt time, which you think about a drum beat. You think about you need to hit a certain target every so often. We set up the line to meet that demand.
Is that part of your job, is to like configure all of this stuff?
Yeah, so there's a couple of parts that go with running the shop. One is making sure that you have all of the parts in place that we need to have. The second is making sure that you get the right people in the right spot doing the right thing. And so we invest a lot of time and technology to make that easier for the operator. When we first started, a lot of the people in the plant probably had the capability to do a lot more of the engine build themselves. And as we've increased in size, we just have to teach people to be really good at one or two operation as opposed to knowing how to build a whole engine. Coach, you ready?
Yeah, Ninja's got it.
There he is.
Pretty good.
This is Ninja.
You're Ninja? Why do they call you that?
Very sneaky.
Sneak up behind people.
He'll be there and you won't even know it. So you've got more equipment designed by our engineering team. And so I'll give you a quick high-level overview, then we'll let Ninja show you how it works. But if you think about installing rings on a piston the old school way, you either got lots of bloody fingers or you got a pair of pliers and you're trying to get that spread and get on there and seated properly. The other thing too is if you're doing thousands of pistons in a day, it could be, one of the failures you could have is to miss a ring, which is bad in an engine. So So our engineering team developed a process that would make it so, you know, even somebody who's never done it before like yourself could step in here and be able to install the rings in the right order on the pistons, and then once that's done, to be able to install the connecting rod in the wrist pin to the piston. So we're gonna have him show you how this works, and then if you want somebody else to take the camera, we'll get a video of it being so simple that somebody who's never done it before should be able to do it. When I say never done it before, never ran it on this machine.
Yeah, I've done it a couple times, you know, by hand. It's not that fun, but
you'll have an appreciation for this after seeing it. So Ninja, why don't you explain to them what you're doing?
Right now we just got a standard 350 kind of piston here. You got your valve releases here. There's little notches set up in there. There's basically no way that this will run without it installed properly the right way. Like it could be upside down and it will not work.
So it won't fit in there with those notches.
Yeah.
Yeah, if you put the notches in there and it doesn't trip those two pieces right there, the machine won't fire. Yep. And so when we talk about mistake proofing and preventing stuff from being done wrong, that's one of the things that's designed into the machine, is for this operation, the only thing that operator really has to pay attention to is to make sure that our logo is face up on that rod. If they do that, we've removed everything else to try to prevent you from putting the piston on backwards.
So we got a magnet here, kind of holds the wrist pin up there.
That's locked and loaded. Now he's going to heat up the piston, so sometimes you'll see people using like a propane burner and almost like a grill top to heat up the pin end.
Yeah, we got the old school way set up over there. But this is all induction heating. It heats it up to about 600 degrees there for you. It usually goes for about 5 seconds. I'll slide it over here. That wrist pin will just push right in. Set up perfectly, positioned perfectly right there for you.
So if you think about everything that can go wrong with getting the wrist pin, the rod, and the piston together, getting them off center, having them get stuck, not having them be the right temperature and things like that, this is all designed by our engineering team to be able to control as much of that as possible. So when we talk about reducing the complexity, if that's the only thing you really have to worry about as an operator and not getting burned, that's pretty simplified from what we're used to doing.
Does Ninja make mistakes?
Occasionally.
not as much on the automated stuff. No. All right, Ninja, you want to train him how to do this, and then we'll let him take a crack at it.
All right, yeah, this is so easy. We had like a 9-year-old kid do it. It'll have all these indications of which direction it'll go or whatever.
So you just look at the picture, copy the picture.
Yeah, you just stick it in there, and it puts the rings right on for you. So that one's showing up or whatever. Stick it in there. You got your first oil rail on.
So when you press it in there, it hits that button and dispenses.
Yeah, it's actually a magnet, I think, where the magnet will hit.
So when it's in there in the right spot, then it'll depress and
depress and shoot one out at a time. It's pretty amazing. Flip it over 180 degrees and stick it in your next one. I'll put your other oil rail right on there for you. So then this one will just go 45 or 90. Do 90. There's your second ring. Do the 180 right here. And then there's your top ring.
That's very satisfying to watch.
Yes, sir.
Is it my turn now?
Yeah, if you want, just go ahead.
Okay, let's see if I can figure this out. If a 9-year-old can do it, I think I'll be all right. Screen goes dark and you want to see what you're doing, just touch it again and then that'll light back up.
Okay.
So, now we've switched roles. I'm going to try to put this together. So I'm taking this.
Now the most important thing is to have a big smile on your face while you do this so everybody knows how fun this is.
Yeah. So we put it up with the F on the top.
Yep.
Because there's no F on this side. I noticed that already. So using my brain here, you just stick it in.
Yep, and pull it out, make sure it seats. There you go. And the next step is going to be one of the first oil rings. Just a slight rotation. The machine will feed the ring on there for you. All right, see it's in place. Got the other side now.
That's the glue on there.
Yeah, I just flipped it 180.
I think it's did it twice.
Might have been a little bit of a delay from how long it was in there. It probably fed a second one.
I messed it up.
Yeah, this is so easy. We had like a 9-year-old kid do it.
You're doing it in the right sequence. We'd probably have to coach you a little bit on speed after some training. There you go, remove, good.
Okay.
The final 2 rings, very, very important.
I did it. I messed up once. Now what happens?
So from there, then it's ready to have the connecting rod installed to it, which we just covered.
So Ninja wants to show us this at game speed.
This is why we call him Ninja.
We want to see game speed.
Hold on.
He put all the pressure on him, he's all nervous.
I am nervous.
That was only about 50 seconds faster than your time, so now you know how good you can be once you're trained like a ninja.
Yeah. Go to ninja school. It's a fun place to work.
Heck yeah, it's awesome. Hearing the motors run is pretty awesome too. You get a big block going, kind of gets your adrenaline going too while you're working.
You ever let out a big whoop when they're done?
Oh yeah.
We got some guys who will let out a big woo every time we dyno an engine, and it sounds great.
Does he put things together faster when there's a big block on the dyno?
You know what? I haven't paid attention enough to find that out. I'm sure he's happier when we're running big blocks all day. I know that.
So they built that whole machine in back there?
Yep.
That's awesome.
Our engineering team did the design, they ordered the components, they assembled it, installed it, programmed it, and everything. So we didn't actually fabricate the 80/20 or the boxes. We bought all of that, but the assembly and everything was done by us. All right, so now we're in assembly. One of the things you'll notice right away is there are less manual torque wrenches and more dedicated specific tools. So you can look on the left side here. These are DC torque tools. It's got a pre-programmed setting that they have to hit. One is for the center bolt, and then one is for the splay bolt on a 4-bolt main. So when they go through and torque, instead of having to do it all by hand or run it in with an air wrench and then finish it, this will actually drive that in and seat the bolt and make sure that it gets torqued to the right set. So from an investment standpoint, you talked about the size of the facility. It's probably at least 2 times larger than our previous facility. And around the plant, you're going to continue to see upgrades and investments in technology. So the light system that you see around the plant, that's to help the operator out. So we got one right here. If you get a yellow light, it means that you've got a part shortage. If you got a red light, it means there's a quality issue. If you got a green light, it means everything is running good. So we're trying to increase our ability to support the team that's doing all of the hard work by getting the engines put together.
Are the little tricks like that stuff that you brought here from your background?
Yeah, if you go into any big engine manufacturer, you're gonna see things that try to make performance visual, whether it's the output of the machine or if it's the flow of parts through the plant. So as we improve our ability to support the team building the engines, making it visual just increases the speed with which we're able to respond and take care of the issues that they have.
Is there somebody paying attention to those lights, or whose job is it to call that out?
Any leader that works on my team is trained to do that. They carry a radio or they have a phone. So if they see an issue, they can call somebody right away and get them here and allow the operator to stay at their station and keep working. This line has been in place for us for about 6 months, but we're still trying to get everything in place to run it the way that we want to. Now this is Jeff. Jeff, how many pistons do you think you've installed in your career?
About 1.5 million.
About 1 million. So he's put in about 1.5 million pistons. If you think about a guy who's put in 1.5 million pistons, they've done it over and over. They're very precise. They do a great job. He catches issues that you would be amazed that he has the ability to tell by how he installs them. But one of our challenges is if Jeff ever wants to have a day off, to put somebody there and have them go do as good as he does, it's challenging without that much practice. So we've got machines that are designed to remove the variation and make it easier for a newer person to be able to do what he's doing with as close to a level of quality you could have if you haven't installed a 1.5 million piston. So you'll see tools like this around the plant that help us increase our flexibility and reduce the complexity of what we're doing. And that's really one of the themes I hope you pick up on around the plant. Less complicated, more flexible, which gives us the ability to control quality better and make it so that we have a very consistent product going out the door.
I have noticed that. You got little tips and tricks everywhere.
Everywhere you go. You know, some of the things that we do, you got an oil pump and a pickup screen, that's sub-assembled together, so when it gets there, he can just put that on the block instead of having to stop, put the pickup screen in, attach it, go through and make sure that gets torqued properly and set before it gets installed. So those are some of the things that we try to do, is have as much product line side as we can so they don't have to leave the line as much. It still happens where they'll run a unique engine and they might not have everything they need, or if something broke along the way, he'll have to get it fixed. But that's our goal, is to have more and more stuff line side to improve our flow. For these aluminum heads, it's a big block Chevy derivative style head. We do an incoming inspection to make sure that they were made right for us, and after that initial inspection is done, they get assigned a part number. That part number is probably going to be the same part number if you go to our website and look for a head kit. That's going to correspond with these numbers. So they get inspected, we go through, we might remove some burrs and things like that that could be bad inside of the engine. Hi, Graydon. We'll go through most aluminum heads don't require very much work, but if you're using like an MLS style gasket or something like that, you've got to be a lot more particular about your surface finish. So this is just a mill. Underneath this guard, there's a head that's got multiple tools on it. It'll rotate. You'll set the head in here, it'll go through, do a pass, and then when it comes out, they'll do an inspection. So they'll check to make sure that the valve can seat in there properly and be at the right spec, and then they'll also check it for surface finish. And I don't see a surfometer, but he's got the ability to put a gauge on the head, and it'll go back and forth, and then it'll give you a reading to make sure we hit the right surface finish. From there, you can see after machining, you get some coolant and some chips and things from machining. So they'll go through a hot dunk wash. That'll get done, dunked and agitated up and down. And then this is the importance of that washer that you saw. You can see it's just a brush and a drill. And so they have to go through and do a lot of those holes by hand with that individual drill. So you think about how many different bolt holes there are to pay attention to. That's where that value of that robot comes in. After they get washed, they get set with valves to make sure you've got the right intake and exhaust valves in them, and then they're staged up for build. One of the things about a head build, when you watch these guys do it, they make it look really easy, but to actually do it the way that they're doing it, there's a lot of different components that they have to get on there. So they got to make sure that, you know, they got the right stem seal on there and that it's seated properly and there isn't a cut or a lip so you don't get a leak. They've got retainers, they've got springs, they've got keepers, they've got all this stuff they have to go in and do. So when they're done, they go through, and when he's going through and he's setting up the station so he can go through and flow when he's building it. But you can see all of the different components that are on there that were needed for the build that he installed here. How long does it take you to build a head?
From there to here, probably like 3-4 minutes. Because I do 5 in a row, and then so it takes time. But
yeah, so once he gets his workstation set up to flow, he just goes through and processes. But if you or I tried to build it, it'd take us, you know, a half hour to get everything to go in place. You start thinking about the keepers. You got any keepers you can look at? So one of the things you have to do when you're building that is you have to get the spring on there, you got to get the seal in there, and you've got to get that valve in there, and you have to get those keepers to seat properly. And they're small and they're flimsy, so if you're not used to doing it, it's really common to have them slip out for a new person. So once these guys develop the touch, they go through and make sure that they can get them on there and that they stay, and they inspect them to make sure that they're right. So this is just a quick gauge where they can go through and press down on it to make sure that it's got the proper amount of resistance on it. So they inspect that, and then we also just do a really quick air check on the ports to make sure that the head doesn't leak after it's been assembled. Thank you.
He's in the zone.
So this is one of the coolest additions. If you've ever installed a head, you'll have an appreciation for it. But before, what these guys used to have to do is we've got a very specific torque sequence and a head gasket conditioning procedure that we do that requires a lot of torquing and turning on it. So our manufacturing engineering team set up this robot station to be able to go through. The operator has the head bolts loosely in there. The robot is a positioning device where it's programmed to get the torque tool to the right place. The torque tool that's on there is a DC torque tool. That's the same thing that you saw at piston install and crank install. So Zach, go ahead and fire it up.
I see the light curtain perimeter around there
exactly.
too.
It's to stop it from running if anybody gets in there. And it's not uncommon to have somebody like myself who's not around it very often to have a shirt or something, you know, just barely catch it, and then these guys got to come reset it. So I try to keep my distance outside of those yellow lines, so that way I'm not the cause of the screw up. Yeah, it's got a predetermined sequence, same sequence that these guys have to memorize and know from their instructions to install. It's programmed in. So once they get the head set and brought around the corner and put in place, the machine takes over a lot of the repetitive motion type work that can increase the wear and tear on an operator. And you know, you think about getting things torqued properly, you can get it over torque, you can get it under torque, you can have it cross thread and give you a false torque reading. So this is programmed. You can see when the box is going off, after it does it, a green light comes on. Every time that green light flashes on that head, and it get a little number that tells you what the reading was for that torque for that step. So what we don't want to see, but does happen sometimes, is if that torque reading is out of spec, it'll flash red and freeze in the spot where it was at, so you can come out and troubleshoot and try to figure out what went wrong.
Where does it go to get the push rods, rockers, and intake manifolds?
We're gonna go there next. You know, we build a variation of engines that have different requirements. Once you get the push rod set, once you get it to zero lash, then you have the amount of turn that you've got to put in, and it varies. We've got stamp steel rockers, we got roller rockers, and so the operator at this operation, they have documentation that tells them what they're supposed to do. But as he goes through and does this, there's a lot of different things he has to pay attention to. You got to make sure that the rocker's set in the right place on the valve tip. You got to make sure that the lash is set properly. If you got a poly lock on there, you got to make sure that not only are they installed properly, but they get locked into place. So there's a lot of very fine details that an operator's got to pay attention to when they're building the engine. It rotates that, you can see the rockers actually move. So now you can see they're in different positions on the engine based off of where the cam is. You want to make sure everything is seated properly, and then now he's going to go through and do the adjustment.
So after they leave here, where do they go now?
We're going to go all the way around the corner to Dyno. How close are you to doing a pull? 5 minutes? 5 minutes to showtime.
All right, well, these guys will see it like that.
So once the engines are built, they'll come around to this stage, and now you're getting ready to customize the engine based off of what a customer wants. So you can see we've got Edelbrock, we've got Wind, we've got our own product line of intakes and dyno components, water pumps, distributor caps, plug wires, things of that nature. So we want to provide options for our customers so they can get what they want. Some guys are going to want a long block with valve covers and a dipstick. Other people are going to want them like this deluxe engine over here. When you start to look at this bad boy, it's got the carburetor, it's got the distributor, plugs, plug wires, fuel pump, fuel lines, water pump, balancer. So There's even a product line that we offer that continues to add more components to it. So transmissions and things like that are part of our offering. So whether you're somebody who wants to do all the work yourself or you want somebody to do it for you, our goal is to get as much content on that engine to make it easier on the install for the customer.
So you can go all the way from just a bare short block or a pair of cylinder heads to whole drivetrain carb oil pan with a transmission ready to rock.
Exactly. And you know, one of the things that we've learned over time, as fewer and fewer people have as much experience working on engines before, the turnkey option, you know, you think about some of those kit cars, you got Factory 5 Super Performance. There's lots of people out there that have these beautiful looking cars and they want a new engine for it. They want to drive it, they want to go have fun with their toy. They might not want to take the time it takes to build an engine, and that gives us the ability to service them and provide them with more and more content to make it, get them in their vehicles that much quicker.
So this is the actual production dyno.
Yep, we've got four production dyno booths that we use in operations, in addition to the ones you saw back in R&D. So there's a lot of money invested as a company in being able to run these engines and put them through a test that will help make sure when they get to the customer's vehicle, we've reduced as much risk as we can. We inspect for leaks. We cut every oil filter 100% and check it to make sure that after it's been through that initial pull, there aren't any issues. We check for blow by. There's a lot of intricate details that we look at on every engine that we dyno. And for us, dynoing every single engine, there's the cool factor about getting your dyno sheet and seeing what your horsepower and torque is. There's also that peace of mind knowing that that engine has been run. We use the same type of gas that a customer can use out in the street. We've got fuel tanks and pumps that get gas to the dynos. These bad boys get run, and they get run pretty hard to make sure that when they leave, we know that they're gonna be a good product. How close are you? Ready? Okay, so the Avis is gonna do an engine pull. We do a couple of small pulls to make sure everything is going up to speed properly, and then you'll hear that one big pull.
That's a small block Chevy. Do you know what it is or what it's supposed to do?
This looks like it's a flat tappet cast iron headed small block Chevy for us with a stroker crank in it. You know, just right around that 6,000 RPM mark, which you're probably not going to do first thing you do once you get the engine installed.
461, 406.
406, 440 in the torque, 461.
So you can see this engine, and every engine has a different spec based off of the components. So when we go through and look at it, he's comparing to make sure that that engine met what it was supposed to. So you can see it beat on horsepower and it beat on torque from what the requirements were for that engine.
So the advertised number on when you buy an engine is the minimum number they can see here?
That's what that's what our target is every time, is to make sure that we're hitting at least what we're advertising.
That's cool.
When you put on a pulley kit and you get this bad boy ready to install, you look at all the boxes in there. Somebody who doesn't do this every day has got a lot to figure out. So when we're doing it here, we've got guys who install pulley kits as one of their primary functions. So they are able to go through, open up the kits, get it sorted out, lay it out, and get it ready. You can see he's getting the water pump ready behind you. So they go through and they get everything set up and then they install it. So these guys are engine enthusiasts. So Dylan behind us here, Dylan, how many cars do you have that you put engines in?
A lot.
So you like to drive demo cars, so you go through repairs. So, you know, when he's not at work, one of his hobbies has to do with automotive type enthusiast hobbies, whether it's doing his demo derbies.
If I'm not here, I'm at the shop most of the time.
So you're pretty much doing the same kind of stuff all day, every day.
Yeah.
So when he leaves for fun, what he does is mirrors very closely to what he does here.
I buy a lot of cars and flip them, so I usually pull motors and trainings and sell those to other buyers, and I flip my other cars. And it kind of depends on the engine, but yeah.
Oh, seems like most of the people here are car enthusiasts. Like,
yeah, either they're like me and they wish they were better at it, or they're like Dylan and they do it for a living. But there is a passion that comes with having this be what we do every day, and the cool factor of knowing where it's going. And if you look at this one, you start to see that's a black throttle body poly sniper fuel injected system. So you've got a traditional carburetor, then you've got a fuel injected throttle body style fuel injection system that we install. So again, lots of different options that we produce or that we have purchased for us that we put on our engines. And then the guy installing this does it over and over, and he does it in his spare time. So I can't propose to you a better way to have it done than to have somebody who does it over and over, and that's our goal, is to make it as turnkey as possible for the end user. You've got an LS 376. It's got our base engine offering on it that we would typically offer, and you can see we've installed, you know, the front drive kit and the pulleys and everything that would need to go with it to help that thing be as close to turnkey as possible. We don't have a transmission on it now, but we do have packages where those transmissions are available, which is a great value for the customer. So after the engines are tested, I mentioned we cut and do a filter inspection on every single one. So we go through and look for anything in the filter that doesn't look right. They get cleaned. We put labels on them. We put a serial number with every single engine, so if somebody has an issue, they can come back to us. And then when it's done, it gets a bag on it to protect it during shipping, and then it gets a crate put around it. So it really takes the mystery on why we call it a crate engine. That's one of the common questions that we get. Well, that's why there's not a lot of scientific knowledge to it. It goes in a crate and out the door.
So who builds the crate for the crate engine?
So we have a company who builds different components of the crate for us, and then these guys put it together. If it's a deluxe engine, like this has got the fuel pump, it's probably got an air cleaner on it, water pump, all of those things. It gets a lot more protection in shipment because there's more that can be damaged. You can also just see the crate style with the open slats on the side. Doesn't require as much protection in transit. So based off of the level of dress, that's what determines the level of sophistication of crate needed to ship.
So this is our research and development department. We're doing some dyno testing on a 632 right now that might be kind of fun to watch. We got it right over here in our first dyno cell.
That's the cool one.
Yeah,
that's the one you want to see.
This is the big daddy. This is the one that makes over 800 horsepower, naturally aspirated.
So what is like the technical rundown on these things?
So our 632's got 11:1 compression ratio. It's a fully forged rotating assembly. It's got our BluePrint engines, 8012 heads on it. It's got an Edelbrock Super Victor intake. So this is actually our dyno mule. So we've had this engine around the research and development department. We've done all of our camshaft testing, cylinder head testing, induction, all sorts of fuel systems. This has been the mule engine that we've used for that. It's got right around 800 dyno poles on it, up to 7,000 RPM. So it's had a hard life, but it's still running great.
With that many poles on it, do you think it'll still make the close to the advertised number?
I think we're gonna find out.
That'd be cool.
Maybe you can do some dyno pulls and we'll see.
I'll try that out. I never ran an engine dyno before, but this thing's pretty freaking sweet. All the way 7,000 RPM. How long is the stroke in one of these?
This is a 4750 stroke.
That's
a 6.635 H-beam connecting rod. It's got Mala Motorsports forged pistons in it. So we dyno test every engine at BluePrint Engines. This is just the research and development department. So we have 3 dyno cells in here where we do all of our development work. And out on the manufacturing floor, we have another 4 dynos for BluePrint Engines.
Is it ready to fire up right now?
She's ready to go.
Well, let's do it. I've watched a lot of videos of people running these things, but never actually witnessed it in person.
Tell it where you want to start the dyno pull and where you want to end the dyno pull. Then there's literally a start stop button that you push after when you want to start the pull, and then after the pull you take the throttle out of it. You want to give it a shot?
Yeah, I'll try it.
All right, take the mouse and click start. Go ahead and just slowly ease into the throttle. You'll see that the dyno brake will start catching the load. Okay, now you're good. Slowly platform is, it's really durable too. Like this is our mule. It's got 800-ish dyno poles on it. We'll call it 810 now. So you can just see how reliable the package is. I mean, you can really beat up on it.
I think it'd be pretty cool in an old Suburban.
Yeah, that would actually be really neat. I don't think I've ever seen one of these in a Suburban.
I can fix that.
Let's fix that. If this one leaves, we're gonna have to get a new mule.
Something's happening right now. Is this what I think it is?
Yeah, it's your 632. Dyno sheets strapped, taped onto it. So, good to go.
There's a 632 in my truck. How about that?
Congratulations, sir.
Thank you, sir. Bro, I got a 632. Got the mule all loaded up. This thing is ready to do some more mule stuff.
Oh yeah.
It was around for 5 years or so, they said,
Yeah.
in R&D department.
Yeah. Used it for testing and for tours. So it's got at least 800 pulls on it.
That's so cool. I like, that's the best way to do it right there.
Yeah, it's well broken.
Oh, good. Well, that just happened. I'm gonna leave this one open-ended, go back to Texas, and unload this thing in a following video that you will see shortly. Also, I filmed a lot of videos in there besides the factory tour, so we're gonna be sprinkling that in. Let me know what you want to know more about this place, you know, like some employee interviews, like how you want to work here, if you want to work at a place like this, all that stuff. Just so much. It's a great trip. I can't wait to get back and tear this thing out of the box and check it out, because this is going to be one serious unit.